Good morning, students. Today we will discuss about terms associated with the photoelectric effect. In the yesterday's class, you already learned that what do you mean by photoelectric effect. You already learned, and as well as you studied very well the experimental arrangement of photoelectric effect here. Once again, the photoelectric effect means this is the emission of electron from the surface of the metal by using the energy as a light energy. For example, whatever it is the light energy you are going to use here, for convenience, I am using here a UV radiation. Why? Because it is having somewhat more frequency compared to other radiations. In order to produce a photoelectric effect, we should use a certain frequency of radiation. Instead of using UV radiation, if you use a red light or else a violet light, then you are not getting a ejection of electron from the surface of the metal. Means there is no photoelectric effect will produce if you use the radiation which is having a lowest frequency. That's why usually in order to produce a photoelectric effect more conveniently, we are going to use which radiation? UV radiation. And today's concept, that is, some terms are there. Those terms are very related to photoelectric effect. That's why the title itself indicating terms associated with the photoelectric effect. In that, the first one is threshold frequency. What do you mean by threshold frequency here? Let us consider, before going to the definition, here just you can observe this experimental arrangement carefully. This is a cathode, also called as an emitter plate or photosensitive metal. This is an anode, also called as a collector plate. Evacuated tube is there. Because why? Because it is, why we are going to call it as an evacuated glass tube? It is free from air particles. And this is a commutator. Multi-key plug system is called as a commutator. In order to measure the photo current, we are going to use the micrometer. And in order to measure the potential difference, we are going to use a voltmeter as an electrical instrument. And to control the current or to vary the resistance in the circuit, we are going to use the electrical instrument as a rheostat. As well as to provide a potential difference, there is an electrical device we are going to use, that is a battery. And next one is, here this is a commutator multi-key plug system. I am connecting this one to, this is a cathode plate. Directly I am connecting it to battery positive, and this one is an anode plate. I am going to connect it for, that is battery negative here. It means that the potential of this cathode becomes positive and potential of anode plate becomes negative. Why? Because why it is a positive potential? This cathode plate I am connecting it to the battery positive and this one to the battery negative. That's why the potential of this plate is a negative and this one is a positive. And here, how to define the threshold frequency? Let us consider this one is the metal. It is having infinity number of electrons. Our intention is to emit the electron from the surface of the metal. Means the emission of electron from the surface of the metal means we need to produce a photoelectric effect. Then what to do? I am taking one radiation. Just you can imagine. This radiation having the frequency is equal to 1 Hz. It is not the standard value. Just you can imagine yourself. I am taking the radiation, its frequency is equal to 1 Hz, because in order to emit the electron from the surface of the metal, the external energy that what I am going to use here, that is a light energy. I am taking one light radiation, its frequency is equal to 1 Hz. Whenever this radiation is incident on the metal plate, there is the energy of this photon or the energy of this radiation is getting transferred to the electron of the metal. Then electron is trying to come out from the surface of the metal. Then this energy given by the radiation is not sufficient for the electron to come out. Then what is happening here? The electron is not ejecting from the surface of the metal. Because why? Because this energy is not sufficient for the electron to come out. Means there is no emission, there is no photoelectric effect. Next, what we can do? I am replacing another radiation. Means I am replacing another radiation. For example, this frequency is equal to 2 Hz. Means I am increasing the frequency of incident radiation. then the energy of radiation getting transferred to the electron, then electron is trying to come out from the surface of the metal. Then if there is no emission of the electron means then there is no photoelectric effect. What is the reason? Here this energy given by the radiation is not sufficient for the electron to come out. Then what we can do? Again I am increasing the frequency of incident radiation. Means I am changing this radiation again. This is the third radiation. This third radiation having certain more frequency compared to first and second. Whenever this radiation is incident on the metal plate having a frequency is equal to 3 Hz, if there is an emission of electron for the radiation having the frequency is equal to 3 Hz, then the photoelectric effect is initiated. For the first radiation having a frequency 1 Hz, there is no emission of the electron, means there is no photoelectric effect. For the second radiation having a frequency is equal to 2 Hz, there is no emission of the electron, means there is no photoelectric effect will take place. For the third radiation having a 3 Hz, if there is a emission of the electron, means yes, the photoelectric effect will start. Among these three, which frequency is minimum or which frequency is required to emit the electron from the surface of the metal? Or else, here frequency is equal to 1 Hz, 2 Hz, 3 Hz. Among these three, which frequency is required or convenient in order to produce an electron from the surface of the metal, or in order to produce a photoelectric effect from the surface of the metal? Then your answer is that is 3 Hz. Then out of these three, which is the minimum frequency required to produce a photoelectric effect? That is 3 Hz. That minimum frequency required to produce a photoelectric effect, that frequency is called as, that is threshold frequency. That is the definition. It is the minimum frequency. It is the minimum frequency. It is the minimum frequency of incident radiation below which no photoelectric effect will take place. Photoelectric effect will takes place. This minimum frequency is called as called threshold frequency. Here, for example, 1 Hz, no photoelectric effect, 2 Hz, no, 3 Hz, no. For example, for 3 Hz, sudden there is an emission of electron, means if the frequency of radiation is lesser than 3 Hz, then you are not getting the emission of the electrons, means there is no emission, photoelectric effect will take place. That's why there is a minimum frequency or suitable frequency required to emit or to take the electron from the surface of the metal. That minimum or suitable frequency is called as threshold frequency. And next one, what is the second term, important term associated with photoelectric effect? That one is stopping potential. Second term, that is stopping potential and also called as retarding potential. Second term associated with the photoelectric effect, that is called as stopping potential, also called as retarding potential. Also called as retarding potential or also called as a negative potential. Here, the title itself indicating stopping potential. What is the meaning of this one? The potential required to stop the electrons. Getting the photoelectric effect means there is a phenomena of emission of the electron from the surface of the metal. Here, this is the important term. Here, the title itself indicating stopping. Stopping means what we have to stop here? The emitting electrons. The emitting electrons from what? That is cathode or emitter plate. Here, the potential is required to stop the electrons which are emitting from the cathode and moving towards the anode. Whatever the electrons here moving towards the anode, those electrons which need to stop here. In order to stop, what we can do? We can use the potential. But here, positive and negative potential is there. Which potential we have to use? That is a negative potential. For example, this anode plate, I am connecting it to battery negative terminal. Means the plate potential become negative and this is connected to battery positive and the cathode plate potential is a positive here. Here, in order to stop the electrons which are moving from cathode to anode, I need to apply negative potential to the anode, because as you know very well, the negative potential and the negative particle, the electron having the charges, the elementary charge of electron is a negative. There is a negative and negative, there is a repulsion, electrostatic repulsion is there. This is a negative potential, means this negative potential repel the electron towards this cathode only. By using this rheostat, what I am doing here, I am increasing the negative potential of the anode. Whenever the negative potential of the anode is boson increases, then there is an electrostatic force of repulsion in between electron and this anode is boson increases. Then as a result, the number of the electrons which are moving from cathode to anode is boson decreases. Just you can imagine, before applying any negative potential, there are 10 numbers of electrons are moving from cathode to anode. Initially, it is not a standard number. I am taking it as an example for convenience. 10 electrons are moving from cathode to anode. By using rheostat, I am increasing the negative potential of the anode. Whenever the negative potential is increases, the electrostatic force of attraction between this negative potential and this electron is boson increases. As a result, the number of electrons, before the 10 electrons are coming, but after increasing the negative potential, for example, the number of electrons moving from cathode to anode becomes 6. Means the number of electrons are moving from cathode to anode decreases, means the photocurrent in the circuit is boson decreases. Next, what we can do by using rheostat, again I am increasing the negative potential. As a result, instead of 6, the 2 electrons are moving from cathode to anode. The number of the electrons becomes decreases, means the photocurrent in the circuit becomes decreases. But our intention is to stop the current. Then what to do? Again you have to using the rheostat, again increase the negative potential. Whenever the negative potential of this anode plate reaches a certain value, then it completely stops the moving electrons. Whenever the electrons what they are moving from cathode to anode become completely zero, then the magnitude of the electrons that is moving from cathode to anode becomes zero in the sense, then the photocurrent in the circuit becomes zero. For a certain value of negative potential, there is a number of electrons from cathode to anode completely becomes stops. The magnitude of the electrons becomes zero in the sense, what is the magnitude of the current in the circuit? That is completely zero. For what potential the current becomes zero, that the negative potential applied to the anode plate is called as negative potential. Then what is the definition? It is the negative potential. It is the negative potential. It is the negative potential applied to or given to anode plate. Given to anode plate. Anode plate for which photocurrent becomes zero, or the ejection of electron from the surface of the cathode completely becomes stops. This potential, this negative potential is called as that what you are given to the anode plate is called as stopping potential. Is called as stopping potential. It's called as stopping potential. And next very important term which is related to photoelectric effect, that is third one, saturation current. This is very important term. Third one is saturation current. Here, what is the meaning of saturation? The meaning of saturation is constant. The meaning of saturation is constant. The maximum constant current is called as saturation current. Just you can observe carefully. And this is the cathode plate, this is the anode plate, and this is cathode, this is anode. I am using one of the light energy, UV radiation. For example, I am taking UV radiation. Let us consider here by using this rheostat. By using the rheostat, I am increasing the potential of anode plate. Here the saturation current means the constant current is there. By using the rheostat, this is battery positive, for example, this is battery negative. I am reversing the connection. By reversing the connection, by using the rheostat, here already that circuit you observed. By using the rheostat, increase the anode plate potential as a positive. Getting the anode plate potential as a positive. By using the rheostat, if you increase the anode plate potential as a positive, then the number of the electrons which are moving from cathode to anode is increases. What is the reason here? However, this plate potential becomes positive, then it attracts more electrons. For convenience, just you can use here. I didn't apply any potential to the anode plate. The number of the electrons which are moving from cathode to anode is 10. Just you can realize it is not a standard number. Now what we can do? I am by using rheostat as an electrical instrument. I am going to increase the anode potential. The anode potential is not a negative. I am increasing. I am making it as a positive, or I am increasing its potential as a positive. After applying its potential as a positive, instead of 10, it is attracting 12 electrons. Getting the number of the electrons are increases, then the photocurrent is increases. In the third step, what I am doing? By using the rheostat, I am increasing further the positive potential of anode plate. However, the positive potential of anode plate is increases, then the number of the electrons they are moving from cathode to anode becomes again increases. Means, for example, becomes 14. The magnitude of the number of electrons becomes which are moving from cathode to anode. The magnitude of the electrons becomes increases, means the current in the circuit is again increases. Again, I am increasing the positive potential. Number of the electrons that is moving from cathode to anode is again increases. Again, the current in the circuit is increases. For a certain value of positive potential, the number of the electrons from cathode to anode becomes same. For example, number of the electrons for cathode to anode becomes positive. Next, what I am doing? Again, I am increasing the positive potential. Then that time also, the number 14, the number of the electrons, that is 14, they are moving from cathode to anode. Here, in the third step, the number of the electrons moving from cathode to anode is 14. But in the fourth step also, after increasing the positive potential of the anode also, the number of the electrons they are moving from cathode to anode is that also 14. Then in the fifth step, what I am doing? Again, by using rheostat, I am increasing the positive potential. That time also, the number of the electrons they are moving from cathode to anode is 14. Means, for a certain value onwards, if you goes on increases the positive plate potential of the anode, the number of the electrons which are moving from cathode to anode becomes constant. Then the current in the circuit becomes constant. This constant current in the circuit is called as saturation current. Here, the definition of saturation current is as the potential of anode is increases for a certain value, but here condition is that you should not change the intensity of radiation as well as the frequency. Don't change the frequency as well as don't change the intensity. Just to change the positive potential of anode plate. Getting as the potential of anode is increases for a certain value for given frequency and intensity. For given frequency and intensity of incident radiation. Intensity of radiation, it means the frequency and intensity should be same. Just can vary the positive potential by using rheostat. Radiation, the photocurrent increases to maximum. The photocurrent increases to maximum and becomes constant. Maximum and become constant. This constant current in the circuit, this constant current is called as saturation current. Is called as saturation current. That is Positive potential increases, then current increases. Again positive potential increases, again current increases. Positive potential increases, again current increases. Positive potential increases, current becomes constant. Positive potential increases, current becomes constant. This constant current is called as saturation current. Please remember these three. One is the threshold frequency, second one is the stopping potential, and third one is the saturation current. These three are important, getting important terms which are associated with photoelectric defect. And the next concept, there is an experiment is there called Hendrich-Lorentz experiment. Getting that one we will see in the next class. Thank you.
Stop, Manoj.